new concept. These old concepts will show the idea of combining like terms and some other things in order to lead us into dealing with the operations with radical expressions. So let's get started. Guys, look at this problem. These are all like terms. Notice I labeled these the letters instead of the numbers. These are kind of like the preview stuff. Guys, if you were going to have this problem, you have 6x, 2x, and 5x, and they're all like terms. You would just combine them. So you would add 6x plus 2x, which would give you what? 8x. And 8x minus 5x would leave you what? 3x. Perfect. On this next one, you have some that have x's and some that have y's. You're going to combine them alphabetically. Okay? So it's going to be the x's go together first. What is 7x minus 6x? X. And then negative 8y and negative 4y combine to give you negative what? 12y. There you go. Can I go any further? Yes or no? No. I can't go any further because one has an x and one has a y. When you're adding and subtracting, you cannot combine things unless they are like terms. Okay, let's go on from here. The next one. Again, review of concepts. This is a review of the concept of distributive property. Before we add in radicals, we're trying to make sure you understand these old concepts. 5 times 8x is going to give us 40x. Plus 5 times 3y is going to give us 15y. Can I add those together? Nope, can't add and subtract when you have different variables. Okay, on the next one, guys, what is the acronym that goes with this? FOIL. F-O-I-L. FOIL. First, outer, inner, last. This is going to continue to show up so much. You've got to know how to deal with this, guys. So x times x would be x squared. X times 3 would be 3x. 4 times x would be 4x. And 4 times 3 would be 12. Is that my final answer? Nope. Why? Combine like terms. Right in the middle, I've got to put these together. We do have like terms here. So it would be x squared plus 7x plus 12. Again, some old concepts because we're about to use them in the new stuff. So just reviewing those concepts. Anybody have any questions before we move on to the new stuff? Mr. Boucher. Okay, here we go. So we're going to do the exact same thing, but instead of having an x or a variable of any kind, we're going to have a radical. But the concept is the same. If they have the same radical, you can put them together. So what's true about all these is they all have a square root of 5, which means they are all like terms. So you're going to do it just like you did when there was an x there. 6 plus 2 is going to give you what? 8. And 8 minus 5 is going to give you what? 8 minus 5 is going to give you what? 3. And then you just put the square root of 5 behind it just like you would. Remember how you wrote 3x? Now you're writing 3 square roots of 5. It's the same concept. Alright, on the next one, guys, when you're dealing with these, it goes from the highest power, usually highest root, down to the lowest one. When you see the keys, that's how they're going to be listed out. So when you look at this, you're going to combine these two together first. So the 8 and the 4 are with the bigger number right here. So 8 minus 4 would give us 4 square roots of 11. Then you're going to put together the one that has the smaller radical with it, which you're going to take 7 square roots of 2 minus 6 square roots of 2, which is going to be what? 1 square root of 2. How do we write 1 square root of 2? Just square root of 2. So plus the square root of 2. Questions, concerns, anything so far? We've mainly reviewed old concepts and shown you how it applies to new ones. We're going to keep doing that. Okay, let's keep going. For the next ones, guys, look at these. Do any of them have the same roots? Does that mean that this is done? Because what's wrong with the 27? It's not simplified all the way out. You haven't taken out the radicals that can come out of it. Guys, we're going to rewrite underneath each one of these, break it into nice and not nice. What goes into 27 that's from that list? 9. And 9 times what gives you 27? 3. You can use your calculator for this, guys. Get it out. If you don't know how to do this quickly in your head, then use your calculators. That's what they're for. Okay, for the next one, you get 8. It breaks into nice and not nice. What goes into 12? 4 and 3. Okay, we're looking at 75. Guys, 75 should be fairly obvious which one of the numbers goes in there. What goes into it? Heard it. 25 goes into it. And how many times does 25 go into it? 3. Do you see that they all are going to have a square root of 3 after them now? We made them into like terms. Let's finish it up so you can see that a little better. Guys, what is the square root of 9? 3. And what is 6 times 3? 18 square roots of 3. Plus, guys, this is not going to be something I'm going to take just an answer on because this takes steps. The square root of 4 is 2, and 8 times 2 would be 16 square roots of 3. Plus 2, oh, no, excuse me, plus, what is the square root of 25, guys? 5, and 2 times 5 would put it at 10 square roots of 3. What can you say about all 3 of these now? They're what? Like terms. So we need to add, grab your calculators, 18 plus 16 plus 10. 18 plus 16 plus 10. 44, and you put the square root of 3 on the end of it. That's it. Questions of any kind? We're about to do the exact same thing on the next one. Questions? Okay, let's break these down, guys. You see how yesterday's is the same? You use yesterday's to do today's. Every single one of these is going to break down in nice and not nice. You're going to set up those two radicals for each one of those. What nice number goes into 20, guys? We've done that a bunch. 4 and 5. We did 45 like 2 times in the worksheet. What goes into 45? 9 and 5. Now stop. If the other two have 5 as their last number, my guess is that 5 is going to be the last number in the... It may not be, but chances are it might be. So try dividing 180 divided by 5 and see if it gives you a nice number for the other number. 36. So it'd be 36 and 5. Does everybody understand why I thought that? Because this one has a square root of 5. This one has a square root of 5. I might as well try to see if this one could have a square root of 5. So I'm going to go through and work out each one of these perfect squares. Get the final answer as we combine them. Square root of 4 is going to be 2, and 2 times 2 is going to be 4 square roots of 5. Plus, the square root of 9 is going to be 3, and 3 times 3 is going to be 9 square roots of 5. The square root of 36 is 6, and there's no number to multiply it by, so it's just 6 square roots of 5. Since they are all like terms, it's just like adding 4x plus 9x plus 6x. We would just combine them all together. What would we get? 19, and then it'd be square roots of 5. 19 square roots of 5. There we go. Any questions, guys? Okay, here's where we start adding some operation stuff into it, more of that than just the stuff we've been doing. This is that distributive property. We did an example like this of the preview stuff. Guys, all you're doing is multiplying across. Two times 8 are the numbers inside the radical. What's 2 times 8? 16. That goes inside your radical. We'll deal with simplifying that in a second. Plus, guys, the 4 is on the outside. There's no number to multiply that 4 on the outside with, so I keep it on the outside. And then I multiply the numbers on the inside. 2 and 3 get multiplied. That's going to be... Don't know where that came from. Is that maybe what it is when you're times 4? All we're multiplying is the 2 times the 3. We okay on that? Okay, just want to make sure. All right, here we go, guys. What is the square root of 16? 4. So this is going to be 4 plus, ooh, does square root of 6 have anything that goes into it that's in that list? Can it divide by 4? And then every number out after that is going to be bigger than 6, so that's not going to work. So this will not break down at all. That's it. Okay, here's the problem with this answer. Just like if you had something that was like 5x plus 2, which term do you write in front? The one with the radical, because just like a variable, the one with the radical would go first. So it would be 4 square roots of 6 plus 4. Would you be marked wrong completely if you did it the other way? No. But would you have points taken off? Yes. You've got to learn to put your radicals in front, just like you put your variables in front. Okay, guys, here we go. Yeah? Oh, here we go. 4 times 3 is going to give us 12. 4 times the square root of 5 is going to give us 4 square roots of 5. 5 times, square root of 5 times 3 is going to be 3 square roots of 5. And then, guys, please, 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 let's get this right. The square root of 5 times the square root of 5 is going to be 5. Thank you. 5. 5. Just 5. Okay. Do you see the like terms? You got the like terms here and here. They both have a square root of 5. And then you've got like terms here and here because they both are constants. They both have just a number. So 4 and 3 is going to be 7 square roots of 5 plus what? 17. Plus 17 on the end. Okay. Have we got 1 or 2 left? 2. Is this the foiling? Yeah, more foiling. Just because foiling gets complicated, we want to make sure you have enough examples of this to make sure you've got it down. But guys, all we're doing is applying old stuff that we learned before to radicals. That's what we're doing today. So let's do this. Are they just on separate slides? Oh, okay. So here we go. Bigger numbers this time. First adder, enter last. Square root of 6 times the square root of 24. I don't know. What's 6 times 24, guys? 144. That's going to be easy. And then 6 times 2 is going to be plus the square root of 12. For the inner 2, you're going to be multiplying 8 times 24. What is 8 times 24? 192. And then the last one is going to be plus 8 times 2. Guys, 8 times 2 is going to be the square root of 16. Now, why are the first one and the last one so easy to deal with? They're perfect squares. The square root of 144 is 12. That's it, 12. The square root of 16 is 4. That's all you do. The 2 in the middle, you have to do a little more work too because you're going to have to break them into nice and not nice. So from here, 12 breaks, guys, we've done 12 several times already. 12 breaks down into what and what? 4 and 3. I don't know 192, but guys, if the other one has a square root of 3 in it, try dividing it by 3 and see if it gives you a nice number. 64. See, if you work backwards, that would have been much easier than trying to go through and divide by all the numbers till you get to 64. So here we go, guys. Square root of 4 is 2. Square root of 64 is 8. So it's 12 plus 2 square roots of 3 plus 8 square roots of 3 plus 4. Now I'm going to be honest with you, this step right here is not necessary if you can see it, but some people have trouble seeing it with all the stuff crossed off and in it. If you can go straight from here to the next step that I'm going to do, then you can skip the one that I highlighted. Okay, if you can just combine like terms from here, you can do that. Guys, if I have 2 square roots of 3 and 8 square roots of 3, that's going to give me a total of what? 10 square roots of 3. Plus, then we're going to add the numbers. The 12 and the 4 go together. So that's going to give me 16 on the end of it. Okay, guys. Last one I want you to try on your own. Try breaking that number down. Try combining things. Try getting it to everything that you need to do. Try that last one on your own, because this is like the first problem on your homework. I mean, not the first one, but I mean, it's like a problem on your homework. So go ahead and try this one. No foiling. There's no foiling. It's just breaking the numbers down and doing it. I just wanted you to try one of the ones like this before you started on your own. Anybody got a final answer yet? Not yet? I'll wait. When y'all get one, let me know. Look at the people around you. Ask them a question. See if they got the same thing you got. Look, because someone's going to have to give me an answer. I'm not just doing it for you. Anybody got one? Yep.
9 squared root of 3 plus 3 squared 5.
Plus 3 squared is 5. Anybody got a different one? I have no idea. I haven't done this one yet. Ian?
6 squared root of 3 minus 3 squared root of 5.
Minus 3 squared is 5. That's what you got? Okay, I have a question. Why would that be wrong immediately? If that's the answer, why would that be wrong immediately? The 5's got to go in front because it's the bigger radical. So we'll just rearrange it. Negative 3 square roots of 5 plus 6 square roots of 3. Let's see. I have no idea. Let's try it. Since a lot of y'all got that, that might be it. Thank y'all for trying, though. Here we go. So we're going to take 3 square roots of 3. It doesn't break down. We put it down here. Minus, we break down the 45. 45 is going to have a nice and not nice. The nice one's going to be 9. The not nice is going to be 5. We bring down the 3 square roots of 3 because it doesn't have anything to combine with. Doesn't simplify over here yet. We'll combine on the next step. So from here, guys, square root of 9 is going to be 3. This is the only one with a 5. I'll rewrite it just so we can see. Some people have a really hard time seeing it from that step. Again, this step is not necessary if you can see it. This one is the one that has a 5 on it. That is the highest root. That's going to be listed first. Negative 3 square roots of 5. Then we're going to combine the square roots of 3, which when you combine those, 3 and 3 would be a total of 6 square roots of 3. There you go. Fix it. If you didn't get it, fix it. Okay, guys. Anybody have any questions before we get going?